So we are continuing with our maximum sum subarray. In the previous video, we had learned how to solve in n square time the maximum sum subarray. But as you know that n square is not efficient, today we are going to learn about Kadane's algorithm. So let me write his name. So it is Kadane's algorithm. What did Kadane's algorithm say? So let me take this particular example only. So 2, 3, minus 8, 7, minus 1, 2 and 3. Okay. So this is 2 here. We would have to calculate the maximum ending. So what does maximum ending tell? Maximum ending tells that till this particular index, what is the sum of the maximum, what is the maximum sum till this particular index. So what would be there in this particular case? It would be since 2 is the first element, therefore 2 would be there. Now 2 is the first element and 3 is the second element. Now in order to calculate the maximum ending for this particular case, either I can consider only 3 or I can consider the value of 2 plus 3, whichever is greater. Okay. So whichever is greater, I would have to calculate that particular value. So 2 plus 3 would be giving me 5, which is greater than 3 and which would be giving me 5. So this particular value has this particular index has a maximum ending of 5. Now for this particular value, that is minus 8. As you know, if I consider minus 8 only, it is minus 8 and it is a lesser value than 5 minus 8, that is minus 3. So minus 3 would be the output here, and for this particular 7, I would be considering this 7 minus 3 or 7. Since 7 minus 3 gives me 4, which is less than 7, so I would be considering 7 directly. And for minus 1, since minus 1 would be less, so I would be considering 7 minus 1, that is 6. 2 is a positive number. 2 plus 6 would be giving me 8, so I would be getting the maximum value as 8 here, maximum ending value as 8 here, and 3 individually is 3 and 8 plus 3 gives me 11. So the maximum ending value is 11 in this case, and thus you can say now we have to find out the maximum among all of this maximum ending values, and then you would be getting your maximum sum of your subarray. That is in this case it is 11. As we had seen in a dry run also, we were getting 11, and according to Kadane's algorithm also we are getting 11. So 11 is the required maximum sum subarray. Okay. Now for the coding implementation part, let's go to our pie chart and let's start implementing Kadane's algorithm. So Kadane's algo. So first we would be creating a max sum 1 function that has the same parameters as add and n as the previous one. Now you would have to maintain 2 variables. One would be keeping in check with for the maximum sum that we have calculated till now, and the other would be keeping in check of the maximum ending till the previous index. Okay, so the 2 variables that are, and both of them would be equal to the element present in the first. Initially would be initialized with the element present in the first index. So it would be let the maximum be saved in the maximum sum would be saved in rest, so rest is initialized to add of 0, and there would be another max underscore ending which would be also initialized to add of 0. Now I would be iterating from the second element to the last, that is from index 1 to n minus 1. So for I in range 1 comma n, now I have to calculate the max underscore ending. So max underscore ending is equal to max of it would be we would be considering either the element that is there, or we would be considering the sum of the max underscore ending along with its element. Whichever sum is greater, I would be assigning it to the max underscore ending. So it would either be the element, or it would be the sum of the max underscore ending plus the element of at ith position. Whichever is the maximum, I would be assigning it to the max underscore ending. Now for the rest would be equal to the max of res, or it would be max underscore ending. Okay, now, and we have to return res, and we are providing the array that we had taken it as a consideration as our input only, and we must get 11 as our output. Let's run our code. Yes, and on successfully running our code, we are getting 11 as our output. Let's check it for other values also. Let's check it for 5, 8 and 3. 5, 8 and 3. Let's run our code. We are getting 16 as our output, and let's check for the last value. Let's check for the last value, that is -6, -1 and -8. So -6, -1 and -8. Let me run our code, and we are getting -1 as our output, as we had desired in this particular case. So this is how you have to implement Kadane's algorithm in order to find out the maximum sum subarray. And as you can see that it is an order of n function without any auxiliary space. So this is how you can improve your particular algorithm for a particular program. So thanks for watching this video, guys. I hope so you liked it, and see you in the next one.